In exercise 7.9, we're told to imagine a bead that is in a rigid circular hoop of radius r lying on a plane. So let's start drawing a hoop. Actually, this one is more of an ellipse. So a circle, okay, in the y-x plane. So let me just move this a little bit. I want to make it perfect. There we go. So y and x plane. Let me draw the other side as well. Okay. So we have y and we have x right here. And we are told that it wants us to use an angle phi. So let me just draw a random like this. Phi, and describe the motion based just on this. So first of all, we know that the radius is always going to be equals to the capital R, which is going to be equals to x squared plus y squared, everything in the square root. Because you can imagine this to be a right triangle. And of course, through the Pythagorean theorem, you know that that's going to be our value at all points. Okay, so now we know that that's a constant. We're just going to call r from now on because it's a constant, so that doesn't matter. And then r can be described in terms of phi as well. Our value on the x will be equals to r sine, r cosine of phi, comma r sine of phi. As you can see, this is pretty easy. Now we were also asked to describe, to write down the equation in terms of, write down the generalized coordinate phi in terms of x and y. All right. So r is always a constant. Phi changes based on x and y. Sorry, here this would be the x value, of course. Let me just make it really clear. Just want to make sure that I'm not confusing anybody. Okay, x and y. Okay, so instead phi, the one described in terms of phi, the one described phi in terms of x and y, I can say that phi is actually going to be equals to the tangent, the part of -1 of, it should be y over x. That would be my final answer. Oh. Because of course we know that the tangent of an angle, I'm just going to call theta right now, not to be sure, it's going to be equal to the sine of the angle over the cosine of the angle. Now we know that sine is equal to the x to the y value in our case, and the cosine is equal to the x value. So I would have the tangent of the angle is equals to y over x. So if I move the tangent on the other side, I will have the angle is equal to tangent of power -1 of y over x. And that would be my final answer.